Alright, my name is Gibbs, and this is the RPM gauge with a shift light attached. I had this idea because I got a car that was a manual, and it was my first manual transmission, and as I was trying to learn how to drive, I realized it would have been a lot easier to learn how to drive it if it had an RPM gauge. So, and I wanted to incorporate LEDs into it, so I decided to add this shift light. My goals were to create an RPM gauge that was simple to install into a car. Just tap into a couple signal wires and the DC. I wanted to run off the 12-volt battery of the car, and I wanted it to be easy enough to use so that the everyday driver would be able to understand how the shift light and everything worked. This is my system diagram. It's got the 12-volt battery in, which leads to the 5-volt regulator, which will step it down so that it can power up the LCD and the LED and the microchip. So I'm getting, and then the tag signal is coming into an optocoupler, which would step down the voltage from the tag signal so that the microcontroller could handle it. And that would power, and that would eventually be able to power the readings on the LCD. These were measured tach signals from my car. Coming in, it was about 8.2 volts to 12 volts AC line, or square wave, sorry. The frequency measurements, this was at low RPMs, this was at idle. It had it was about 15 hertz or 14.5 hertz. About mid-rev, I just guessed it was about 37 hertz. And this was almost redlining the car at 64 hertz. This is my board design. This is the input from the got the 12-volt battery, it's got the tach signal line in the middle, and then it's got it's got the ground, battery signal, and then the tach signal. That's going to come down. This is the optocoupler, which would step down the voltage but keep the same frequency. And this is the voltage regulator. Yes. I chose the 7805 voltage regulator. It called for a 7 to 25 volt input, which 12-volt battery fits those specs perfectly. Outputs 5 volts typically. And this was the design that I had to use to incorporate it into my board design, and that was pretty simple. It wouldn't take up a lot of space on the board, so it worked perfectly. This is the optocoupler I chose. Like I said, the point of it is to drop the voltage down so that the microchip can handle the voltage. I'm using 3 volts from VDD, so instead of going from 8 to 12 volts like the input signal line, it would be 0 to 3 volts, but with the same frequency. The specs for this optocoupler were ID of 60 milliamps and a voltage drop of 1.5 volts across the diode. So to design for this resistor, I did Vin minus the voltage drop, and then divided it by, I did half ID just to be safe, which is 30 milliamps. That gave me 350 ohms, but I used 330 ohms standard value. This is my soon-to-be 3D printed gauge mount. This is the shift light cylinder, which is supposed to hold 4 LEDs in it. This little lip will be where the lens rests on, and I'll be able to, the other side of the cylinder is the same. This will just hold up in there with 4 LEDs, with the wires being able to come out of that hole. And the LCD should be able to just fit snugly right in here with a few mounting screws on the sides, just into the plastic. moral concerns. It will help drivers who are new to manual transmission. Can prevent damage of your motor by avoiding over revving it and under revving it, etc. It'll reduce pollution if you don't know how to drive a manual very well and you over rev it a lot. This will hopefully cut down on that. Any questions?
If you go back to your waveform pictures,
Yeah.
so okay, so you actually have it written there, measured AC. Let's say 8.2 volts equals 12 or up to 12?
Oh, this supposed to be a hyphen.
Okay.
Right. 2 volts.
So the blue line in every case is essentially ground?
Yeah, I didn't turn off channel 2, but
Right, but that's a good ground reference.
yeah.
Okay, so when you skip ahead to your optocoupler slide, so where is that signal going to that?
That signal comes into the bottom of that with the cathode.
Right, so your formula
Yep.
says that Vn is 12 volts.
Well, we've got V in of 12 volts coming down through here.
Okay, so where does the 8 volts fit?
Oh, where it's the 8 volts from the signal line?
Yeah.
Well, they've. I'm not sure actually.
So you're thinking about the problem correctly, but you didn't calculate your resistance correctly.
Okay.
Because there's 8 volts somewhere. It's never 0 volts.
Right.
That signal never goes to 0, so the optocoupler never sees the entire 12 volts. So we can work on that
Okay.
a little bit. It doesn't change your design at all. You still need a resistor there. But
It just
you put
changes the
that
value,
resistor
right?
in, it won't work. Okay.
Okay.
we've got
Well, it
that.
worked when I built it on the breadboard and it still worked with 330 ohms.
Okay. Well, that's probably more a matter of the fact that the specs for the optocoupler are pretty loose. And
Yeah.
you just got lucky. Were you driving it with a 8 to 12 volt signal?
Yes I was.
But then there's a good chance it will work. I would just after this, we'll go through the formula again and see if we get the 8 volts in there, how close it is. Yeah, so I think, I don't have any other questions. Does anybody else? Oh, I know what, so the whole idea of the shift light, what?
I didn't explain that very well. So the shift light would be, there would be 3 colors. There'd be red, green, and yellow. Yeah, the shift light would be red if you are in too low of RPMs or too high of RPMs. So that's when you want to shift immediately, or else you're harming your car. The yellow is, or the green is the optimal range of RPMs, which you want to be in for what gear you're in. And then when it turns yellow, it's kind of like a warning light, shift as soon as you can.
Okay, so you're gonna be using those strip LEDs?
Yeah.
Okay, and you said there's 4 of them?
Yeah, I was going to try to fit 4 in around the cylinder.
Okay, they're all showing the same color at the same time?
Yep.
You just want brightness from them?
Yeah, basically.
Okay. And what exactly are you gonna program into the micro to make the decision when it's time to shift? What's your data?
I need to write a frequency response program
Okay.
well, first I need to take the range and find out what range of frequency I want to be the red LED, the yellow LED, and the green, and then
So you're on the right track. So you've got to write some software to first of all calculate the frequency, and then you got to make a decision.
yeah, I just don't have that.
Based on what? Maybe a user's manual for the car that says shift in this zone kind of thing?
Yeah, I was gonna look up I've been driving manual for a little bit, so I know
Yeah,
I
so you
should
have to-
shift.
Yeah. In fact, I think I've never had a car with a shift light, but my understanding is you can change the range and you have it for sort of best economy, switch
Yeah.
on the dash kind of thing. So if you want to be a race car driver today, you set the high performance one. If you want to save energy, you set it for optimal performance.
And that would be mostly software,
And
right?
it's all
And
it's
just
all
switch on the
software,
outside.
yeah. It's just making the decision when to turn the light on.
All right, so I could probably put that in for time.
All right, any other questions? Thank you.